This is Swapnil Bhartiya and welcome to State of Energy. Today we have two guests from Alliander, Jonas Vanden Bogaard, solution architect at Alliander, and Frank Kreuwel, product owner and data scientist at Alliander. Frank, Jonas, it's great to have you on the show.
Yeah, thanks for having us.
And today we are going to talk about a new or the newest open source project at LF Energy is OpenSTEF. Frank, can you tell us what is this project all about?
Yeah, so the OpenSTEF project is about forecasting the load on the grid and either energy consumption or generation from renewable sources. And it's really aimed at forecasting for the short term, so hours to days ahead.
Perfect. Can you also talk about what is the need of this project? Or if you look at, grid, there are other, programs that, they do know just to give some insight into, hey, what the load will look like. So if you can tell, this is why we needed that project and that's why it was created.
Yeah, so I work at the Dutch distribution system operator, and we see that the load on the grid is increasing due to a lot more electricity being used. Also switching from gas-powered heating to electricity-powered heating. A lot of electric vehicles, and also the consumption is of the generation is changing. So a lot of renewable production, and this also makes the load on the grid much more fluctuate. And this is for us really tricky. So it's increasing and fluctuating a lot, so that in more and more areas of the grid we see that the load actually reaches the constraints of the grid, and then we want to actively balance and make sure that the grid isn't stressed too much. And for this we need accurate predictions of what the load will be.
Okay. Can I ask one more question, which is also, you're talking about different sources. Now, homeowners or businesses, because of solar, they're also becoming producers. We have solar roofs and we are putting electricity back into the grid. So that is also changing. So can you also talk about the need of this kind of system in place, because the way we are producing electricity and the sources from it's coming is also different. It's no more one-way traffic, is both ways.
Yeah, so it's a good point that you raised. So the grid that's currently in place actually was installed decades ago. And decades ago, electric vehicles or like putting solar panels on your house or wind turbines somewhere in the field, it really wasn't a thing. It didn't exist yet. So the grid that we put into the ground 30 years ago wasn't designed to have this both inflow and also outflow of energy. And we see that this, especially for neighborhoods with a lot of houses, with a lot of solar panels, can be really tricky, because if you design the grid for a lot of energy consumption, then you design it differently than if you know that there's also going to be production at some times of the day.
One more question would be that you did touch upon that, you alluded to that, but how is Alliander already using OpenSTEF internally?
Yeah, so we use it for three main goals or use cases. So first, to detect where in our grid congestion can occur, so that we already know, okay, tomorrow this grid area has a high chance of being congested. So we can already do something to mitigate this congestion. That can either be sending a signal to a company there to shift their plant energy consumption, or send a signal to a renewable source of renewable energy to don't feed in a very large peak back to the grid, but slightly less. So the first area where we use OpenSTEF is to balance the grid ourselves. The second one is to deliver forecasts to the TSO, so the national grid operator, so they can perform a national grid safety analysis. And thirdly is we are at Alliander currently investigating quite a number of smart solutions to actively balance the grid. So either by smart charging electric vehicles or using battery storage on a neighborhood level. And to facilitate such smart solutions, forecasts are required of the load in that area. So that's also which we use OpenSTEF for.
Excellent. Thanks for explaining how it's been used. Now, Jonas, I want to hear from you. Of course, we have covered all the open source projects from Alliander, but tell us, why and when Alliander decided to open source OpenSTEF project.
So at Alliander, we feel it's really important to deal with costs associated with digitalization in a responsible way, and also think about the place in society that Alliander occupies. And by using open source, contributing to open source projects and making some of our internal projects open source available, we really aim to bundle the investment costs, but also the knowledge and the development capacity required with other organizations to meet the challenges of the energy transition Frank was already talking about. So why OpenSTEF in specific had three reasons. First of all, we see that a lot of organizations in the energy sector are working on the short-term forecasting capability. And secondly, we also see that many organizations are reinventing the wheel and building their own solutions. And third, we really believe that by open sourcing OpenSTEF, this would be an enabler for more collaboration around the forecasting capability in the energy sector. Hopefully saving us and others money, but also most importantly, to really speed up innovation and to tackle the challenges we have to face today, and especially also tomorrow.
And this project is one of the great examples, of open source, where sometimes a lot of open source projects are created, is from the scratch. They did not even hit, 1.0 release. So sometimes they are not ready for productions. They are still evaluated. But this project, as Frank was saying, it's already been used internally at Alliander. So how mature is this project already? How ready it is for production? I mean, it's already running in production, right?
Alliander, it is already used in production. So it's for us, it's one of our key projects and one of our key systems we use to do our daily responsive task, both on the three ways Frank was already explaining. We needed to fulfill our tasks in relation to making forecasts for the national grid operator, but also we needed to manage and balance the grid and to deploy new smart solutions Frank was also talking about.
As Frank explained, that the project is already being used at Alliander, but it's becoming an LF energy project now. So how mature is this project? Is this the same project that Alliander is using internally, so it's ready for production, or this project as OpenSTEF is at an early phase? So the basic idea is to make it clear for companies who want to use the project, how mature, how ready it is. That's the question.
Actually, the code base, which is publicly available in the OpenSTEF project, also on GitHub, that's exactly the package that we use at Alliander internally. So when we make a new, if we see something we need to improve the forecasting pipelines, then that change is being made to the open source project. And internally we imported them back, or we deploy it internally to use this improvement. So the project is, I really dare to say that it's really fully mature. And we're now really in the stage of making it usable beyond the scope of the Alliander use cases. So that's also why we have this partnership with RTE, and we're really happy that they are also contributing since beginning of last year. So that we know for sure that the use case at Alliander is really not only living at Alliander, but also useful for other parties. And that's really, I think, the stage where we are in now.
As you just mentioned, that it is ready, other organizations can use it. And also you mentioned RT and other folks are already working on it. What kind of organizations should be interested in this project, or they can benefit from it?
Yeah, so I think all organizations like active in the energy sector who want to do something with forecasts, so it can be a distribution or a transmission system operator, or an energy provider, or a balanced responsible party, but also more like from the academic point. So we use a lot of machine learning techniques, which really are like state of the art. But developing new machine learning techniques isn't our expertise. Our expertise really is applying them in an operational context and providing use case in which such algorithms can be applied. So if you were working at a university and developing new kinds of machine learning algorithms, then this could also be a project which really you could use to make sure that your algorithm is really being used and really like adds value to society in that way.
Jonas, if I ask you if there are organizations who do want to get involved, not just as a consumer of the project, but become part of the community so they can also collaborate, what is the best way where they can find more information and how they can get involved?
We just launched the OpenSTEF projects page at lfenergy.org. And if you want to learn more about OpenSTEF and stay up to date, that's really a good place to start. And also, if you really want to dive in OpenSTEF in more detail, I really advise you to have a look at our GitHub community at github.com/OpenSTEF, where you can get started with OpenSTEF and also get into touch with the OpenSTEF team. And also, if you're interested, contribute to the OpenSTEF project.
What kind of roadmap do you have? What release plans you have that we will be dropping this release in this month? Do you want to have a regular release cadence like every 6 months or every year, or are you planning, when the release are ready? So can you just share, what the project's roadmap looks like?
Yeah, so currently we have a technical steering committee meeting once every month where we decide on like big architectural topics, or so that's something we have every month. Every 2 weeks we have a refinement with all active collaborators to also help each other refine user stories. Like if someone wants to add a new feature, assess, how can we accommodate this most sensibly in the existing code base. Apart from that, we use the CI/CD release strategy. So if you have a new feature you want to add, then you just create a pull request, and then contributors will have a look. And if it's deemed okay, then it's included in the code base, and then it's released as a new version of the package, like the OpenSTEF package, which you can then decide for yourselves if you want to incorporate this automatically, like in your own project, or do this once every major update, or less frequently. And also the roadmap is something that each contributor determines from their point of view, and we then get together and make sure that these roadmaps are aligned, and that if we are planned to work on the same topic, that we know to find each other, and if we plan to work on different topics, that we know that we aren't in each other's ways, but this is coordinated.
The fact is, a lot of these open source projects, they also leverage a lot of other open source project libraries are there, frameworks are there. Some projects live within LF Energy, some projects live outside of LF Energy. So can you also talk about what are the core components of OpenSTEF project?
Yeah, so I think the core component are the automated machine learning pipelines that turn historical data and additional features into a forecast of what the load on the grid will be. And for this we make use of as much open source packages as we can, or as makes sense, I should say. So the machine learning pipelines, machine learning algorithms itself are open source, publicly available. For example, we use LightGBM a lot. Also all the tooling from sklearn, which is the default package for machine learning in Python. But also in other points of our tool stack. So we use a Influx database as a time series storage, Grafana as a user interface, Docker to build our images.
Nowadays, carbon emission, cutting carbon footprint is becoming, a very important topic these days. So can you also talk about what role does this project play in not only helping, organizations understand, where their energy is coming from, and also kind of help in the bigger goal, which is to cut down on our carbon, footprint. Can you talk about that?
Yeah, so I think there are, two links that immediately pop into my mind. The first is that we use these forecasts of the load on the grid to actually also see where there is unused potential of the grid. And to really make the most out of the grid capacity that is available to allow, for instance, solar parks or wind parks to feed in really as much energy as physically safe, instead of having to use safety limits, which are always very on the conservative side. These forecasts enable us to integrate more renewable energy into the grid. And the second one is that with this tooling, we also have a module where typically we measure the net load on the grid, which is a combination of energy consumption and generation. And within this tooling, there's a module to disaggregate this net load into gross consumption and generation from wind or from solar or from different renewable sources. And this also, well, at least in our case, it allows us real insight in what types of energy are running through the grid, which we then can use in subsequent analysis to, if we want to calculate grid losses or find the optimum grid topology or connectivity at any given moment.
Yeah, I think Frank set out the most important benefit is that we really want to enable the transition to more renewables, to make that possible and to get the most out of the grid and make sure we use all the capacity in the grid to add as much solar and wind energy and other renewables to the grid as fast as possible.
Yeah, maybe to make it really concrete, if that's okay. So it used to be the case up to last year that if you were a big wind farm and you wanted to have a connection somewhere and there wasn't really 10 days a year, there wasn't enough capacity for the grid to allow you, then we would have to say, well, sorry, we can't connect you because 10 days a year, the grid will then not be safe. And this tooling is one of the parts to move to a new level of distribution system operator, where we can already today assess if tomorrow will be one of those 10 days where there isn't enough capacity. And if today we think, well, tomorrow we have an issue, we can already send out a notification. So this allows us to, well, not have to say no to this wind park, but say, okay, you can be connected under the condition that for 10 days a year, the capacity can't accommodate you. But then we will let you know a day in advance when that is the case.
Does that also mean that, while right now when we look at the project, look like it's more or less like a short-term prediction, short-term forecast, but does that also mean that over a period of time, you will have more data so you can also have yearly predictions as well that, hey, at this point of the year, I mean, of course, you already have the data, but at this point of where the peaks happen, so we should be more prepared. Do you see a scope beyond, just, short-term forecast as well through this project?
Yeah, so it's also from it's a very interesting point that you raise. And we also heard this when discussing the roadmaps for this year, also with RTE, so the other collaborator in the project. This topic also popped up. So you use a short-term forecast to manage something in real time, but integrating these smart solutions that you are managing in real time, you've already done beforehand, and then you did some long-term analysis. So this long-term analysis is also something that's, it goes hand in hand with the short-term operations. Currently, these are two separate steps or separate applications. But in my mind, it completely makes sense to integrate these at some point, or at least integrate their functionality.
Frank, Jonas, thank you so much for taking time out today and talk about OpenSTEF project. And as you're saying, there's so much work going on. So I would love to have, other stakeholders of the project as well and have more discussions. So I'd love to have you folks back on the show. Thank you for your time today.
Thank you.
Yeah, thanks for having us.